Hi everyone. Today we are discussing on another topic, that is methods to overcome the intraocular barriers. In the last 2 days, two sessions we discussed on what are the various barriers for the permeation of the drug into the eye. So as we know, since there are so many barriers in our eye, the amount of drug reached into the retina or amount of drug reaches into the posterior segment of the eye is very less. That is, the therapeutic concentration, the achievement of the therapeutic concentration of any drug in the eye is a very difficult task because of this presence of so many barriers. Thus, we opt various methods to overcome those barriers. By opting any of these methods, this helps to enhances the bioavailability or enhances the therapeutic concentration of the drug in the eye. So let us go into the topic. The methods to overcome the intraocular barriers includes generally three methods. That is, use of penetration enhancers, then use of drug carrier system, and the third one is use of mucoadhesive polymers. Let us discuss one by one. So this session we will go deep into the use of penetration enhancers. Penetration enhancers are the chemical substances used as an excipient along with the drug formulations, and these substances will help in the permeation of the drug into the eye. The penetration enhancers might work with various mechanisms. Mainly, they weaken the intracellular junctions, the tight junctions, and helps in the permeation of the drug molecules. The penetration enhancers are of different types, and all this works under different mechanisms, and some work in the same mechanism itself. The first one is the calcium chelators. Second is the purely surfactants. The third one is preservatives. Fourth penetration enhancers are glycosides. Fifth one is fatty acids. Sixth are the certain miscellaneous penetration enhancers and certain bioadhesive penetration enhancers. Let us go one by one. The first one is the calcium chelators. As we know, the main example is EDTA. So EDTA functions by loosening the tight junctions of the epithelial cells. So this tight junction, if it's become loose, there will be penetration of drug more through this pores. Now 0.5% of EDTA has proved it has doubled the ocular absorption. The second one is the surfactants. The surfactants may help in the permeation of the drug through both the transcellular as well as the paracellular routes, that is, to the intercellular as well as to the intracellular pores. The drug molecules can be permeated with the help of the surfactants. Epithelial cells surrounded by the outer membrane. As we know, this outer membrane are made up of heavy phospholipids. Now, how the surfactants works? The second mechanism is it removes the phospholipids, that is, removes the phospholipids from the membrane. Once it removes the phospholipids from the membrane becomes looser and that observes a dose dependent penetration by the surfactant. Dose dependent penetration by the surfactant means what? As the amount of surfactants gets increases, the penetration also gets increases. So that is how the surfactants works. As we know, the various types of surfactants, among the first one is the non-ionic surfactants. So this non-ionic surfactants has proven in increasing the permeability of the ethanol, timolol, etc. Example is polyoxyethylene 9 lauryl ether. So this is found to be the most effective non-ionic surfactant for the permeation of ocular drugs. The number of oxyethylene groups in the molecule as well as the HLB value of this molecule plays a major role in enhancing the permeability. The two things, the first thing is the number of oxyethylene groups and the HLB value of the molecule. This surfactant has proven to increases the bioavailability of various drugs. The next classes of surfactant is bile acids as well as the salts. So they are again amphiphilic molecules. They are having both polar as well as a non-polar groups. There is a single molecule that is having both polar as well as non-polar groups. So they works by, how do they work? They works by changing the rheological properties of the biological membrane. The rheological properties, or the property that helps in the movements. So they alter the rheological properties of the biological membrane, as well as by changing they are also act as the mucolytic properties. So as a mucolytic property, they induces the change in the structure of the membrane, thereby it increases the permeability. So because of their mucolytic property, they changes the structure, in the sense they can make some modification in the structure, or they can modify the rheological property of the biological membrane, thereby it can enhances the permeability. Thus these bile salts or the bile acids increases the permeability of the hydrophilic drug molecules through the pore-like routes such as the intracellular channels. So this helps in the permeability of hydrophilic drug molecules. Then next one is the lysophosphatidyllipids. They are also the amphiphilic surfactants. They affect, how do they work? The intracellular proteins and the polar groups of the phospholipids in the intracellular space by formation of certain channels and permeating the penetration of water and substances through this channel. So this lysophosphatidyllipids works by affecting the intracellular proteins of the membrane and the phospholipids of the membrane. Again, they works on these proteins and the phospholipids, thereby permeating the drug molecules or the water through this pores. The third class of penetration enhancers are the preservatives. So as we know, the preservative has its own property, but at the same time the preservatives can also be used to enhances the permeation of the drug molecule. Basically, the benzalkonium chloride and cetylpyridinium chloride as used. So how this benzalkonium chloride works? They works by highest promoting the they works by loosening the tight junctions or reducing the thickness of the tight junctions, or they works by removing the epithelial cells or peeling of the epithelial cells in the membrane. So as a proof, they have shown 0.01 percentage of benzalkonium chloride shows a corneal epithelial peeling, which helps in penetration of the drug molecule. If you administer multiple doses of benzalkonium chloride also, what happens is, even though it damages or it reduces the thickness of the epithelial cells, it is not penetrating into the chamber, into the anterior chamber, whereas it's accumulating within the epithelial cells. So what the advantage of benzalkonium chloride says, it peels out the epithelium, it reduces the thickness of the epithelium, it weakens the epithelium cells, thereby it helps in penetration of the drug molecule. But what happens is, even though the benzalkonium chloride peels out the epithelium, it is not penetrating into the anterior chamber, it is remaining or it is accumulating only in the epithelial cells. And they found to enlarge the intracellular spaces in the superficial cells of the cornea. So enlargement of the intracellular spaces is one of the reasons for increasing the permeability of drug. The next one is the cetylpyridinium chloride. It's a proven in such a way that it's proven for the use of penicillin penetration across the rabbit cornea. Even more that they are shown by de-epithelialized cornea. That means administration of the cetylpyridinium chloride for the penicillin and a rabbit eye proved that they helps in penetration of the penicillin molecule into the posterior segment. And how much it helps in penetration means it is better than the de-epithelialized cornea. That means even though the epithelial cells of the corneas are there also, this cetylpyridinium chloride is act as a fast penetration agent in permeating the drug substances. The fourth class is the glycosides. So glycosides, the main two classes, that is saponin and digitonin, helps in permeation of the drugs. Saponin is again a naturally occurring glycoside available in the plants. They are again having amphiphilic in nature, having both polar as well as the non-polar groups. So and they function even at a 0.5 percentage, they enhances the corneal permeation, and at 1% they proven and act as a promoter for systemic absorption also. So saponin has a proven bio-enhancer even at 0.5 percentage as well as in the 1%. Digitonin again another non-ionic surfactant which helps in the permeation of the drug molecule. How do they work? What is the mechanism? That is, they solubilizes the membrane cholesterol. In surfactants we have seen they solubilizes the phospholipid. The same way here also they solubilizes the cholesterols in the membrane, resulting in what? Resulting in exfoliation of the epithelium. Okay, so the removal or the peeling of the epithelium or reducing the thickness or the strength of the, because once the cholesterol has been, as we know, the membranes are made up of the lipid molecules. Once the lipid is being taken out, the membranes become weaker. That's only the concept here. And again, the digitonin, which produces a significant alteration or a complete removal of the epithelial cells. Even though it increases the absorption of the drug molecule, they shows a significant alteration or a complete removal of the epithelial cells. So we need to evaluate how is the safety of using the digitonin for the as a penetration enhancers. It's not only with the case of the digitonin only, but with other penetration enhancers what we are discussing now. Even the benzalkonium chloride also as a preservative, again used as a penetration enhancers. The safety of all these drug molecules, all these penetration enhancers must be evaluated properly before going to develop or use in the case of development of any of the drug delivery systems. Fatty acids. These agents act as an absorption promoters by affecting both cell membrane and tight junctions and by forming ion pair complexes with the cationic drugs. So these fatty acids are also used to do enhances the permeation of the drug, and they functions with the general mechanisms as by forming ion pair complex with the cationic drugs. And the second last class is the miscellaneous class, that is two substances like ozone and cytochalcines. Ozone is a proven transdermal absorption promoter. They enhances the transcorneal permeation of hydrophilic drugs but retard the permeation of the lipophilic drugs across the membrane. And they change in the structure and the fluidity of the barrier membrane because of the high lipophilicity and sequestration in the epithelial cells. So these azones substances which generally enhances the penetration of the hydrophilic drug molecules by altering, what is the mechanism? By altering the fluidity of the barrier in the membrane, means the membrane becomes the more fluid. So by changing or altering the fluidity of the barrier membrane, this azones helps in penetration of hydrophilic drug molecules. The next one is the cytochalcines. They are also again a small naturally occurring heterocyclic compounds which also enhances the corneal permeability with a minimum damage to the membrane. So that's all about the penetration.